Hello, and welcome to Math Lessons with Linda. Today's topic is evaluating composite functions. If you are unfamiliar with evaluating functions, you may want to pause and go brush up on that and then come back. Composite functions are when we have two functions that we are working with simultaneously. Our functions today are f of x, which is 2x minus 5, and g of x, which is x squared plus 1. So when you evaluate a function, you're substituting in a value for your variable, in this case it's x, and then you are coming up with what its value is. It looks like this when you evaluate a composite function. So we notice that we're using both f and g at the same time in the same problem. The way to tackle this is you start with the innermost function first. In this case, it's g. So that tells us we're going to use this function first. And what we want to do is just pull out this g of 3, and we're going to plug in the 3 for the x value. And we're going to figure out what that is. So g of 3 is equal to 3 squared, which is 9, plus the 1. So g of 3 is 10. So what we've done is we've come up with the value for the function g at 3, which is 10. So what I do next is I go back up to my original functions, and instead of this g of 3, I'm going to plug in the 10. So now instead of f of g of 3, it's f of 10. These are the equivalent values. This tells me now I'm going to go back and I'm going to use this 2x minus 5. And everywhere I see the x, I'm plugging in this 10. So 2 times 10 minus 5 now. This is the second part of the composite function. So f of 10 is going to be 20 minus 5. So f of 10 is equal to 15. This is my final answer after I've done 2 sets of evaluating for this problem. Let's try one more. Let's reverse the order that we are evaluating our functions with. So notice now that I put the f function on the inside. That means we're going to evaluate this function first. So I'm going to do f of negative 2. I'm going to start with my f of x function here. So that means 2 times negative 2 and then minus 5. So f of negative 2 is negative 4 minus 5. So f of negative 2 is negative 9. So this f of negative 2, which I saw at the beginning, is now going to become negative 9. So I have g of negative 9. And I'm going to go over to this function and I'm going to plug in this negative 9. When you plug in a negative and you are squaring it, remember to put your value with the negative inside the parentheses, then square it. So now I have g of negative 9. When I square negative 9, which means negative 9 times negative 9, I get 81 plus 1. So that means g of negative 9 is equal to 82. Okay, one more and let's see what happens with this. What if what we're substituting in isn't a number at all? What if we do something like this? F of g of w. So I don't have a numerical value for what I'm evaluating. I just have a different variable. All that tells me is that instead of the x, I'm going to put in a w everywhere I see x. So instead of x squared, this becomes w squared. And then I'm finished with this part of the problem. There's no number I can come up with. This is what I'm going to now put in for the g of w. So this becomes f of w squared plus 1. So that means everywhere that I see this x in my original function f, I'm going to plug in this w squared plus 1. So 2, and then in parentheses, w squared plus 1, and then we have to do the minus 5. So this requires a little bit of distributive property. So I'm going to have 2w squared plus the 2, and then now I can drop the parenthesis and I have my minus 5. These are like terms. So when I do my final evaluation, I'm going to have 2w squared and then a minus 3. And this would be my answer. It's not a number. It's still going to have that variable in there. Those are some examples of how you can evaluate composite functions.